R squared. This is a very interesting parameter. A lot of people use it, and sometimes they use it without knowing the underlying principles of R squared. So let's quickly get a understanding of what R squared is, because we will be using it too. So last time we stopped over here, we talked about the simple linear regression being constructed through the ordinary least squares method, where we are minimizing the sum of squares of those differences yi minus yi hat. And basically we are looking at what the model is predicting and what is actually happening at a certain level of experience, or at a certain level for the independent variable. And we're looking at that difference, we're squaring it, we're summing it for all of the observations we have. We're counting that sum, and then the line that has the smallest sum will be the best fitting line, or will be the simple linear regression model. So let's get rid of that call out for a second, and let's remember this value. So we'll need it just now, and in fact this value has a name. It's called the sum of squares of residuals. So we'll just label it SS res. And now let's do something else with our chart. We'll get rid of those lines. So this is our raw chart with the observations. And instead of drawing the regression line, let's draw the average line. So this is your average salary across all of your observations. Now let's do the same exercise and project our observations onto this line. And now if we calculate the distances, the red distances, and we square them, then it'll look like this. It'll be yi minus y average squared, and then we'll take the sum of all of these distances. Now this value also has a name, and it's called the total sum of squares. And what R squared is, R squared equals to 1 minus sum of squares of residuals divided by total sum of squares. And so what this is saying is that there will always be a sum of, or total sum of squares, right? So the average, not all, your records are not always going to be all equal to the average, otherwise it's a very boring data set. So sum of the total sum of squares will always be some sort of value. And what you're trying to do with your regression is you're trying to fit a line to minimize, as we discussed previously, to minimize the sum of squares of residuals, to make it as small as possible, right? So in a way, the way to think of it intuitively is the average line, which we have on the chart right now, is also a type of a trend line. It's just horizontal, right? It's not sloped, it's just a horizontal trend line, but it kind of also is. So you can think of it as a model that is fit to a dot. It's not the best model, but it's just y average. So what you're trying to do by fitting a sloped line and minimizing the sum of squares of residuals is you're trying to fit the best line. And what R squared is telling us is, it's telling us how good is your line compared to the average line, which anybody can think of, right? So it's not hard to take the average. You take a calculator, you get the average. But in order to fit the best fitting line, you have to actually run a linear regression. And if you look at the formula, so you're trying to minimize SS residual, right? So sum of squares of residual. So on the right over there, that part of the formula, as you minimize SS residual, it goes smaller. It always becomes smaller. And that way, SS residual divided by SS total becomes smaller, and 1 minus SS residual divided by SS total becomes greater. So ideally, if your SS residual is 0, so basically your trend line that you're modeling goes through all your records, then in that case, R squared is equal to 1. And that's the ideal scenario. But that normally never happens. So the closer R squared is to 1, the better. The further away it is from 1, so the lower it is, the worse. A good question is, can R squared ever be negative? The answer is yes, of course R squared can be negative, and that is if your, for instance, SS residual actually fits your data worse than your average line. It's hard to do, but you gotta try, because if you, I don't know, if you just draw a random line, I guess, then facing the wrong way, so here it would be going downwards, then probably yes, you would get a negative R squared. So that means that the model is completely broken. It's better to use the average and even to use the model. But normally, so R squared is normally between 0 and 1, never gets greater than 1, and the closer it is to 1, the better.